Question 1. System analysis indicates a manufacturing facility has implemented a new production process that generates a unique byproduct. As the certified safety professional, you are tasked with ensuring compliance with the Resource Conservation and Recovery Act, RCRA. What is the most appropriate initial step to manage this byproduct from a regulatory and safety perspective? Option A. Conduct a thorough waste characterization to determine if the byproduct meets the definition of hazardous waste under RCRA, considering both listed and characteristic criteria. Option B. Rely on the waste disposal vendor's assessment of the byproduct's hazardous nature without independent verification. Option C. Immediately classify the byproduct as hazardous waste and implement stringent management protocols to ensure maximum compliance. Option D. Assume the byproduct is non-hazardous and dispose of it through standard industrial waste channels, as it is a new process and unlikely to be regulated. The correct answer is C. Immediately classify the byproduct as hazardous waste and implement stringent management protocols to ensure maximum compliance. Explanation. Scenario analysis. This scenario presents a common challenge for a certified safety professional, CSP, operating under the U.S. regulatory framework, specifically the Resource Conservation and Recovery Act RCRA. The challenge lies in balancing the immediate operational needs of a manufacturing facility with the long-term environmental compliance and liability associated with hazardous waste management. The CSP must interpret and apply complex RCRA regulations to a practical situation involving a new process, ensuring both worker safety and environmental protection without creating undue burdens or misinterpreting regulatory requirements. Potential for significant fines, legal action, and reputational damage underscores the need for meticulous attention to detail and a thorough understanding of RCRA generator status, waste determination, and management standards. Correct approach analysis. The correct approach involves a systematic, regulatory-driven process. This begins with a thorough waste characterization to determine if the byproducts of the new process are indeed hazardous under RCRA. This determination is critical and must be based on either listed wastes F, K, P, U lists, or characteristic wastes, ignitability, corrosivity, reactivity, toxicity. If hazardous, the facility must then accurately determine its generator status, very small quantity generator, or large quantity generator, based on the monthly accumulation of hazardous waste. This status dictates specific management requirements, including storage time limits, container management, personnel training, contingency planning, and record keeping. The CSP's role is to ensure all these steps are followed meticulously, consulting with environmental engineers or waste management specialists as needed, and documenting all determinations and actions. This approach represents best professional practice because it directly adheres to RCRA mandates, minimizes the facility's environmental liability, and ensures compliance with federal and state environmental laws. It prioritizes a proactive, informed decision-making process grounded in regulatory requirements. Incorrect approaches analysis. One incorrect approach is to assume the waste is non-hazardous without proper characterization. This is a significant regulatory failure because RCRA places the burden of proof on the generator to demonstrate that a waste is not hazardous. Ignoring the potential for hazardous characteristics or listed waste can lead to improper disposal, resulting in substantial fines, cleanup costs, and potential criminal charges. Ethically, this approach disregards the CSP's responsibility to protect both human health and the environment. Another incorrect approach is to manage the waste as hazardous without a definitive characterization, simply to err on the side of caution. While seemingly protective, this can lead to unnecessary costs and operational inefficiencies. More importantly, it may result in misclassification of waste streams, potentially leading to non-compliance if the waste is actually non-hazardous and managed under stricter, inappropriate hazardous waste protocols, or if a truly hazardous waste is overlooked due to a lack of specific focus. The regulatory framework requires accurate determination, not blanket overmanagement without justification. A third incorrect approach is to rely solely on the advice of the waste disposal vendor, without independent verification or understanding of the underlying RCRA requirements. While vendors are valuable resources, the ultimate responsibility for hazardous waste determination and management rests with the generator. Delegating this responsibility without due diligence is a regulatory failure and a breach of professional duty. The The CSB must understand the regulations to effectively oversee the vendor's services and ensure compliance. Professional reasoning. When faced with a new process generating potential waste, a CSB should employ a systematic decision-making process. First, identify the potential waste streams. Second, conduct a thorough waste characterization, consulting ARCRA regulations 40 CFR Part 261 for listed and characteristic hazardous wastes. This may involve laboratory analysis. Third, based on the characterization, determine if the waste is hazardous. Fourth, if hazardous, determine the facility's generator status. 40 CFR Part 262. Fifth, implement the appropriate management standards based on generator status, including proper storage, labeling, manifesting, and record keeping. Sixth, ensure personnel are adequately trained. Throughout this process, maintain clear documentation of all determinations, analyses, and management practices. Engage with environmental experts and legal counsel when complex issues arise. This structured approach ensures regulatory compliance, minimizes liability, and upholds professional ethical standards. Question 2. Examination of the data shows that a manufacturing facility operating under a U.S. EPA-issued National Pollutant Discharge Elimination System (NPDES) permit has consistently reported effluent monitoring results below the established permit limits for the past 2 years. However, a recent internal audit revealed that the sampling methodology used for one of the key parameters has not been updated to reflect the latest EPA-approved methods, and there is evidence of potential bypass events during heavy rainfall that were not formally documented or reported as required by the permit. What is the most appropriate course of action for the certified safety professional to take? Option A. Advise management to immediately cease all operations until a new sampling methodology can be implemented, and all past bypass events are thoroughly investigated, regardless of the immediate operational and financial impact. Option B. Conclude that since all reported data is within limits, no further action is required, as the facility has demonstrated compliance based on the submitted information. Option C. Immediately initiate a comprehensive review of the NPDES permit, investigate the historical sampling data for potential impacts of the outdated methodology, assess the frequency and nature of the bypass events, and develop a plan for corrective actions, including potential permit modification or reapplication if necessary, while ensuring all findings are transparently communicated to management and the regulatory agency. Option D. Focus solely on updating the sampling methodology to the latest EPA-approved methods and disregard the historical data and bypass events, assuming that future compliance will be assured with the new methodology. The correct answer is C. Immediately initiate a comprehensive review of the NPDES permit, investigate the historical sampling data for potential impacts of the outdated methodology, assess the frequency and nature of the bypass events, and develop a plan for corrective actions, including potential permit modification or reapplication if necessary, while ensuring all findings are transparently communicated to management and the regulatory agency. Explanation. This scenario presents a common challenge for certified safety professionals, CSP, operating under U.S. federal regulations, specifically the Clean Water Act, CWA, and its associated National Pollutant Discharge Elimination System, NPDES program. The challenge lies in interpreting and applying complex regulatory requirements to a real-world operational context, balancing compliance with economic realities and potential environmental impacts. The CSB must demonstrate a thorough understanding of NPDES permit conditions, monitoring requirements, and reporting obligations to ensure the facility operates legally and responsibly. The correct approach involves a systematic review of the facility's NPDES permit, identifying all applicable effluent limitations, monitoring frequencies, and reporting deadlines. It requires proactive engagement with the environmental team and potentially regulatory agencies to clarify any ambiguities and ensure accurate data collection and reporting. This approach exemplifies best professional practice by prioritizing regulatory compliance, environmental stewardship, and transparent communication. It aligns with the ethical obligations of a CSB to protect human health and the environment, as well as the legal requirements of the CWA. An incorrect approach would be to assume that because no exceedances were reported no further investigation is necessary. This fails to acknowledge the possibility of unmonitored discharges or inaccurate reporting, which are significant regulatory and ethical failures. It demonstrates a lack of due diligence and a passive approach to environmental compliance, potentially leading to violations and penalties. Another incorrect approach would be to focus solely on the immediate cost of corrective actions without considering the long-term legal and environmental consequences of noncompliance. This demonstrates a failure to understand the broader implications of environmental regulations and the CSB's role in risk management. It prioritizes short-term financial gains over regulatory adherence and environmental protection. A third incorrect approach would be to dismiss the potential for impact based on a general understanding of the facility's processes, without consulting the specific permit conditions. This highlights a critical failure to apply specific regulatory knowledge to the situation. It assumes a level of expertise that bypasses the essential step of verifying compliance against the legally binding permit. The professional reasoning process for similar situations should involve 1. Thoroughly understanding the relevant regulatory framework, in this case, the CWA and NPDES program. 2. Meticulously reviewing all applicable permits and their specific requirements. 3. Proactively identifying potential compliance gaps or areas of concern. 4. Engaging in clear and consistent communication with relevant stakeholders, including operational staff, environmental teams, and potentially regulatory agencies. 5. Documenting all findings, actions, and communications. 6. Prioritizing actions that ensure compliance and mitigate environmental risk. Question 3. Performance analysis shows that a manufacturing facility stores several chemicals on site. One chemical, a solvent, is classified as a flammable liquid and an irritant under OSHA Hazard Communication Standard. The facility has 8,000 pounds of this solvent present on site at its peak inventory during the reporting year. Another chemical, an oxidizer, is present at 12,000 pounds and is classified as an oxidizer and a health hazard. A third substance, a laboratory reagent, is present at 400 pounds and is classified as an acute toxin and is also listed as an extremely hazardous substance A's. Which of these chemicals, if any, must be reported under EPCRA Section 312 Tier Roman II reporting requirements? Option A. The solvent, the oxidizer, and the laboratory reagent. Option B. Only the laboratory reagent. Option C. The solvent and the oxidizer. Option D. The oxidizer and the laboratory reagent. The correct answer is C. The solvent and the oxidizer. Explanation. This scenario presents a common challenge in environmental health and safety management, ensuring accurate and timely reporting of hazardous chemicals under regulatory mandates. The professional challenge lies in interpreting and applying the specific requirements of the Emergency Planning and Community Right to Know Act (EPCRA) as implemented by the U.S. Environmental Protection Agency (EPA) for Tier Roman II reporting. Misinterpretation or oversight can lead to significant penalties, hinder emergency responders' ability to protect the community, and damage the organization's reputation. Careful judgment is required to distinguish between reportable and non-reportable substances and to correctly determine thresholds. The correct approach involves a thorough understanding of EPCRA Section 312 and its associated regulations, specifically 40 CFR Part 370. This regulation mandates that facilities report hazardous chemicals present on site above certain threshold quantities. The key is to identify all chemicals that meet the definition of a hazardous chemical under OSHA Hazard Communication Standard, 29 CFR 1910-1200, and then to accurately track their inventory to determine if they exceed the reporting thresholds, typically 10,000 pounds for most hazardous chemicals, or 500 pounds or the threshold planning quantity, whichever is less, for extremely hazardous substances. This approach ensures compliance with federal law, supports community right know principles, and provides crucial information for emergency planning. An incorrect approach would be to assume that only chemicals with the most severe hazard classifications require reporting. This fails to recognize that EPCRA definition of a hazardous chemical is broader and includes substances with a range of health and physical hazards, as defined by OSHA. Another incorrect approach would be to only report chemicals that are actively used in large quantities, neglecting those stored on site, even if temporarily, that exceed the threshold. This overlooks the plain language of the regulation, which focuses on present at the facility. A further incorrect approach would be to rely solely on safety data sheets, SDS, without cross-referencing them with EPCRA reporting thresholds, as an SDS may list hazards but not explicitly state if a chemical meets the reporting quantity for Tier Roman II. Professionals should employ a systematic decision-making process that begins with a comprehensive inventory of all chemicals on site. This should be followed by a review of each chemical's SDS to determine its OSHA hazard classifications. Subsequently, the facility must meticulously track the maximum daily inventory of each hazardous chemical to compare against the EPCRA reporting thresholds. Regular audits and updates to this inventory are crucial to maintain ongoing compliance. Question 4. The assessment process reveals that a municipal water treatment plant is experiencing challenges in consistently meeting the required residual chlorine levels throughout its distribution system. The plant utilizes an automated online chlorine analyzer for continuous monitoring and also has basic colorimetric test kits available for field use. The safety manager needs to ensure the effectiveness of the disinfection process and worker safety. Which approach best addresses these dual concerns while adhering to regulatory requirements for public water systems? Option A. Implement a regular calibration and verification schedule for the automated online chlorine analyzer using a calibrated, field-portable spectrophotometer for residual chlorine testing, and supplement this with a strategic sampling plan at various points in the distribution system. Option B. Focus all monitoring efforts on the initial point of chlorine addition, assuming that if the residual is adequate there, it will remain so throughout the entire distribution network. Option C. Increase the frequency of visual color comparison testing using the existing kits at the plant's entry point to the distribution system, assuming this will provide sufficient data to manage residual levels. Option D. Rely exclusively on the automated online chlorine analyzer, assuming its continuous readings are inherently accurate and sufficient for regulatory compliance and operational oversight. The correct answer is A. Implement a regular calibration and verification schedule for the automated online chlorine analyzer using a calibrated, field-portable spectrophotometer for residual chlorine testing, and supplement this with a strategic sampling plan at various points in the distribution system. Explanation. Scenario analysis. This scenario presents a common challenge in water treatment safety management, balancing operational efficiency with regulatory compliance and worker protection. The professional is tasked with ensuring a critical process, disinfection, meets stringent public health standards while also addressing potential hazards. The challenge lies in selecting the most effective and compliant method for monitoring residual disinfectant level, which directly impacts both water potability and worker exposure risks. Correct approach analysis. The correct approach involves utilizing a calibrated, field-portable spectrophotometer for residual chlorine testing. This method is best professional practice because it aligns with established water quality standards and regulatory requirements for monitoring disinfectant residuals. Regulatory bodies like the U.S. Environmental Protection Agency, EPA, under the Safe Drinking Water Act, ESTWA, mandate accurate and reliable monitoring of disinfectant residuals to ensure microbial contaminants are effectively controlled. Calibrated spectrophotometer provides quantitative, objective data that can be compared against established maximum residual disinfectant levels, MRDL, and minimum residual disinfectant levels, MRL. This ensures the treatment process is effective and that public health is protected. Furthermore, this method minimizes direct worker contact with concentrated chemicals compared to some other testing methods, contributing to a safer work environment. Incorrect approach is analysis. One incorrect approach is relying solely on visual color comparison kits for residual chlorine. While these kits may offer a preliminary indication, they are inherently subjective and lack the precision required for regulatory compliance. They are prone to interpretation errors, especially under varying lighting conditions or by different personnel, leading to potentially inaccurate readings. This failure to obtain precise, verifiable data violates the spirit and often the letter of regulations requiring accurate monitoring for public health protection. Another incorrect approach is to assume that the automated online chlorine analyzer is sufficient without independent verification. While automated systems are valuable for continuous monitoring, they can malfunction, drift out of calibration, or be affected by interferences. Relying solely on such a system without periodic, independent field testing creates a significant risk of undetected process failures. This constitutes a failure in due diligence and a potential violation of regulatory requirements for verification of treatment process effectiveness. A third incorrect approach is to only test residual chlorine at the beginning of the distribution system and not at various points downstream. Disinfectant residuals can decay over time and distance due to factors like temperature, organic matter, and pipe conditions. Failing to monitor at multiple points means potential breaches in disinfection effectiveness in parts of the distribution system could go unnoticed, posing a direct risk to public health and violating the comprehensive monitoring requirements of public water system regulations. Professional reasoning. Professionals must adopt a systematic approach to water treatment safety. This involves 1. Understanding the specific regulatory requirements, e.g., EPA-ESTWA state-specific regulations for the water system. 2. Identifying the critical control points for disinfection and the parameters that must be monitored. 3. Selecting monitoring methods that are accurate, reliable, and meet regulatory standards for precision and objectivity. 4. Implementing a robust calibration and verification program for all monitoring equipment, including automated systems. 5. Establishing a comprehensive sampling plan that accounts for potential variations in disinfectant residual throughout the distribution system. This structured approach ensures both compliance and the protection of public health and worker safety. Question 5. Analysis of the potential ecological impacts of a proposed industrial facility expansion on a nearby wetland ecosystem. A CSP must determine the most effective approach to ensure environmental protection and regulatory compliance. Which of the following represents the most professionally sound and ethically responsible course of action? Option A. Proceed with the expansion based on the assumption that if the project meets minimum regulatory requirements, significant ecological harm is unlikely. Option B. Conduct a comprehensive, site-specific ecological risk assessment to identify potential hazards, evaluate risks, and propose mitigation strategies, ensuring alignment with best practices in environmental stewardship and regulatory expectations. Option C. Rely on generalized industry environmental impact guidelines, assuming they adequately cover the potential risks associated with the expansion in this specific location. Option D. Delegate the entire responsibility for evaluating ecological impacts to an external environmental consulting firm without active oversight or integration into the overall safety management plan. Correct answer is B. Conduct a comprehensive, site-specific ecological risk assessment to identify potential hazards, evaluate risks, and propose mitigation strategies, ensuring alignment with best practices in environmental stewardship and regulatory expectations. Explanation. Scenario analysis. This scenario presents a professional challenge for a certified safety professional, CSP, by requiring them to evaluate the ecological impact of a proposed industrial expansion. The challenge lies in balancing economic development with environmental stewardship, a core ethical responsibility for safety professionals. The CSP must navigate potential conflicts between operational efficiency, regulatory compliance, and the long-term health of local ecosystems, which can have indirect but significant impacts on worker health and community well-being. The absence of specific, predefined ecological impact assessment, IA, data necessitates a proactive and informed approach to data gathering and analysis. Correct approach analysis. The correct approach involves conducting a thorough, site-specific ecological risk assessment. This aligns with best professional practices and the overarching principles of environmental stewardship often embedded within professional codes of ethics for safety professionals. Such an assessment would identify potential hazards to local flora, fauna, and water bodies, evaluate the likelihood and severity of adverse impacts from the expansion, e.g., increased emissions, altered drainage patterns, habitat disruption, and propose mitigation strategies. This proactive, data-driven methodology ensures that potential ecological harm is identified and addressed before it occurs, safeguarding both the environment and the long-term sustainability of the operation. This approach is consistent with the general duty clauses found in many occupational safety and health regulations, which require employers to provide a workplace free from recognized hazards, including those that may arise from environmental degradation impacting the community, and by extension, the workforce. Incorrect approaches analysis. One incorrect approach is to rely solely on generalized industry standards for environmental impact without a site-specific evaluation. This fails to account for the unique ecological characteristics of the proposed expansion site, potentially overlooking specific vulnerabilities or sensitive species. This approach is ethically deficient as it prioritizes expediency over due diligence and may lead to non-compliance with environmental regulations that mandate site-specific assessments. Another incorrect approach is to assume that minimal regulatory oversight implies negligible ecological impact. Regulatory frameworks often set minimum standards, and a responsible safety professional must look beyond mere compliance to identify potential risks. This approach demonstrates a lack of professional judgment and an abdication of the ethical responsibility to protect the environment and community health. It also risks future legal and reputational damage if unforeseen ecological consequences arise. A third incorrect approach is to defer all ecological considerations to an environmental consulting firm without active CSB involvement or oversight. While specialized expertise is valuable, the CSB has a fundamental responsibility to understand and integrate environmental risks into the overall safety management system. This passive approach can lead to a fragmented understanding of risks and a failure to connect ecological impacts to broader occupational health and safety concerns. It represents a failure to exercise professional leadership and a potential breach of ethical duties. Professional reasoning. Professionals should approach such situations by first understanding the scope of their responsibility, which extends beyond immediate workplace safety to encompass the broader environmental context. This involves identifying potential ecological hazards, assessing their risks using a systematic methodology, like a risk assessment, and developing a plan for mitigation and monitoring. Collaboration with environmental specialists is encouraged, but the CSB must maintain an active role in integrating ecological considerations into the overall safety management system. Decision-making should be guided by a hierarchy of controls, prioritizing elimination or substitution of hazardous activities, followed by engineering controls, administrative controls, and finally, personal protective equipment, applied to both occupational and environmental risks. Ethical consideration, including the duty to protect human health and the environment, should always be paramount. Question 6. The control framework reveals a need to optimize environmental safety processes within the organization, considering OSHA regulations, which approach best aligns with a proactive and continuously improving occupational safety and health program. Option A. Prioritize immediate remediation of any identified environmental spills or releases, and then proceed with reporting as required by OSHA. Option B. Concentrate efforts on fulfilling all OSHA reporting obligations for environmental incidents, ensuring timely submission of all necessary documentation. Option C. Focus on meticulously documenting all existing environmental controls and procedures, ensuring they meet the minimum requirements outlined in OSHA standards. Option D. Develop and implement a comprehensive hazard communication program and robust emergency preparedness plans, integrating environmental hazard identification and control into the overall safety management system. The correct answer is D. Develop and implement a comprehensive hazard communication program and robust emergency preparedness plans, integrating environmental hazard identification and control into the overall safety management system. Explanation. The control framework reveals a common challenge in occupational safety and health management, balancing proactive hazard identification and control with reactive incident investigation. In this scenario, the professional is tasked with optimizing environmental safety processes within the context of OSHA regulations. The challenge lies in moving beyond mere compliance to a state of continuous improvement, ensuring that environmental hazards are not only managed, but that the management systems themselves are robust and effective. This requires a deep understanding of OSHA intent, which is to prevent workplace injuries and illnesses, and to apply this understanding to environmental aspects that directly impact worker safety. Correct approach represents best professional practice because it focuses on integrating environmental safety into the overall safety management system, aligning with OSHA performance-oriented standards. By prioritizing the development and implementation of a comprehensive hazard communication program and robust emergency preparedness plans, the safety professional is addressing the root causes of potential environmental incidents and their impact on worker safety. This proactive stance, grounded in OSHA General Duty Clause and specific standards like hazard communication, 29 CFR 1910, 1200, and Emergency Action Plans, 29 CFR 1910. 38. Demonstrates a commitment to preventing harm rather than just responding to it. It fosters a culture of safety, where environmental risks are understood and mitigated before they manifest as incidents. An incorrect approach that focuses solely on documenting existing environmental controls without assessing their effectiveness or seeking improvement fails to meet OSHA expectations for a dynamic safety program. This approach is a mere checklist exercise, lacking the analytical rigor required to identify systemic weaknesses or opportunities for enhancement. It risks overlooking emerging hazards or outdated control measures, thereby failing to uphold the general duty clause's mandate to provide a workplace free from recognized hazards. Another incorrect approach that prioritizes immediate remediation of identified environmental spills over a systemic review of preventative measures is also professionally deficient. While immediate response is crucial, it addresses the symptom, not the cause. This reactive posture, without a subsequent analysis of why the spill occurred and how to prevent recurrence, represents a failure to optimize the control framework. OSHA expects organizations to learn from incidents and implement corrective actions to prevent future occurrences, not just to clean up after them. This approach neglects the preventative aspect of environmental safety management. A third incorrect approach that solely focuses on meeting minimum OSHA reporting requirements for environmental incidents, without a broader strategy for hazard identification and control, is also inadequate. Reporting is a compliance obligation, but it is not a substitute for a comprehensive safety program. This approach demonstrates a compliance-driven mindset rather than a safety-driven one, failing to leverage incident data for proactive risk reduction and continuous improvement, which is the essence of effective occupational safety and health management under OSHA. The professional decision-making process for similar situations should involve a systematic evaluation of the current control framework against OSHA regulatory requirements and best practices. This includes 1. Understanding the specific environmental hazards present in the workplace and their potential impact on worker safety. 2. Reviewing existing control measures for their effectiveness and compliance with relevant OSHA standards. 3. Identifying gaps and areas for improvement in hazard identification, risk assessment, control implementation, training, and emergency preparedness. 4. Developing and implementing a prioritized action plan to address identified deficiencies, focusing on both immediate corrective actions and long-term systemic improvements. 5. Establishing metrics to monitor the effectiveness of implemented controls and to drive continuous improvement. Question 7. Operational review demonstrates a proposal to modify an existing manufacturing process that may result in an increase in emissions of volatile organic compounds, VOC, and nitrogen oxides, NOx. The facility is located in an area designated as attainment for these pollutants. The proposed modification is intended to improve production efficiency and reduce operational costs. What is the most appropriate initial step for the certified safety professional to take to ensure compliance with federal air quality regulations? Option A. Conduct a detailed prevention of significant deterioration, PSD, applicability assessment to determine if the proposed modification triggers PSD review, and if so, identify applicable control technology requirements. Option B. Perform a quick review of the estimated emission increases, and if they appear to be below historical averages, proceed with the modification without further regulatory consultation. Option C. Inform management that the modification can proceed as planned, focusing solely on the projected cost savings and efficiency gains. Option D. Proceed with the modification, assuming that since the facility is in an attainment area, PSD regulations will not apply to this specific change. The correct answer is A. Conduct a detailed prevention of significant deterioration, PSD, applicability assessment to determine if the proposed modification triggers PSD review, and if so, identify applicable control technology requirements. Explanation. This scenario is professionally challenging because it requires a safety professional to balance operational efficiency with stringent environmental regulations, specifically the prevention of significant deterioration, PSD program under the Clean Air Act. The core challenge lies in accurately assessing the potential impact of a proposed modification on air quality and ensuring compliance without unduly hindering necessary business operations. This requires a nuanced understanding of PSD applicability, control technology requirements, and the process for obtaining necessary permits. The correct approach represents best professional practice because it directly addresses the regulatory requirements of the PSD program. By initiating a thorough PSD applicability assessment, the safety professional is proactively identifying whether the proposed modification triggers PSD review. This involves evaluating potential emissions increases against established PSD thresholds for regulated pollutants. If PSD review is triggered, the next step of identifying best available control technology, BACT, is mandated by the Clean Air Act for new or modified major sources. This ensures that the most effective emission reduction techniques are implemented, thereby preventing significant deterioration of air quality. This approach is ethically sound as it prioritizes public health and environmental protection in accordance with federal law. An incorrect approach that involves proceeding with the modification without a formal PSD applicability assessment is a significant regulatory failure. This bypasses the fundamental requirement of the PSD program, which is to determine if a permit is needed before construction or modification begins. This could lead to violations, penalties, and the need for costly retrofits if non-compliance is discovered. Ethically, it demonstrates a disregard for environmental stewardship and legal obligations. Another incorrect approach, which is to assume the modification does not trigger PSD based on a cursory review of emission estimates, is also a regulatory failure. PSD applicability is a complex determination that often requires detailed analysis of potential emissions, including fugitive emissions and emissions from all affected equipment. Relying on assumptions rather than a systematic assessment can lead to underestimation of impacts and noncompliance. This approach also fails to uphold the ethical responsibility to protect air quality. Finally, an approach that focuses solely on the operational benefits of the modification without considering its environmental implications is a critical ethical and regulatory failure. While operational efficiency is important, it cannot supersede environmental protection mandates. This demonstrates a lack of understanding of the safety professional's role in ensuring compliance and protecting public health. The professional decision-making process for similar situations should involve a systematic risk-based approach. First, clearly define the proposed operational change and its scope. Second, consult the relevant environmental regulations, in this case, the Clean Air Act and its PSD provisions. Third, conduct a thorough PSD applicability assessment, meticulously evaluating potential emissions increases against PSD thresholds. If PSD is triggered, proceed with BACT analysis and permit application. Document all assessments, decisions, and communications. Engage with regulatory agencies early and often if there is any uncertainty. This structured process ensures compliance, minimizes environmental impact, and upholds professional integrity. Question 8. Research into the implementation of an environmental management system, EMS, at a U.S.-based manufacturing facility has revealed a need to align with ISO 14001. The safety professional is tasked with developing a strategy that ensures both adherence to the ISO 14001 standard and compliance with all applicable U.S. federal environmental regulations. Which of the following strategies best reflects a comprehensive and compliant approach? Option A. Develop an EMS based on the principles of ISO 14001, ensuring that all identified environmental aspects and impacts are addressed, and then cross-reference these elements with specific requirements of U.S. EPA regulations, e.g., ARCRA Clean Air Act, Clean Water Act, and relevant OSHA standards to confirm alignment and identify any gaps. Option B. Focus exclusively on meeting the explicit requirements of U.S. federal environmental regulations, treating ISO 14001 as a supplementary guideline that can be adopted only where it does not conflict with existing legal mandates. Option C. Prioritize the adoption of ISO 14001 clauses that are easily measurable and quantifiable, while deferring the integration of less tangible aspects of environmental management and regulatory compliance until a later phase of implementation. Option D. Implement the ISO 14001 standard as written, assuming that its international recognition inherently guarantees compliance with all national environmental laws, and deferring any specific regulatory review until after certification. The correct answer is A. Develop an EMS based on the principles of ISO 14001, ensuring that all identified environmental aspects and impacts are addressed, and then cross-reference these elements with specific requirements of U.S. EPA regulations, e.g., RCRA, Clean Air Act, Clean Water Act, and relevant OSHA standards to confirm alignment and identify any gaps. Explanation. This scenario is professionally challenging because it requires a safety professional to navigate the complexities of implementing an international standard within a specific organizational context, ensuring compliance not just with the standard itself, but also with relevant national regulations that may interpret or supplement the standard. The challenge lies in balancing the global framework of ISO 14001 with the localized legal and operational realities. Careful judgment is required to avoid superficial implementation that meets the letter, but not the spirit of the standard, or that creates conflicts with existing legal obligations. The correct approach represents best professional practice because it demonstrates a thorough understanding of both ISO 14001 requirements and the applicable U.S. regulatory framework. By integrating the standard's principles with specific U.S. environmental laws and OSHA requirements, the safety professional ensures a robust and legally sound environmental management system. This proactive integration prevents potential noncompliance issues and fosters a culture of genuine environmental responsibility, aligning with the ethical obligation of a safety professional to protect both human health and the environment. An incorrect approach that focuses solely on the ISO 14001 standard without considering U.S. regulations would be professionally unacceptable. This failure would lead to a system that might be certified, but could still violate U.S. environmental laws, exposing the organization to significant legal penalties, reputational damage, and potential harm to the environment. It represents a failure to uphold the professional duty to ensure legal compliance. Another incorrect approach that prioritizes only U.S. regulations and treats ISO 14001 as secondary would also be professionally deficient. While U.S. regulations are mandatory, ISO 14001 provides a structured framework for continuous improvement and proactive environmental management that goes beyond minimum legal requirements. Ignoring its systematic approach would result in a less effective and less comprehensive environmental management system, missing opportunities for efficiency and pollution prevention. A third incorrect approach that attempts to implement ISO 14001 in isolation, without engaging relevant stakeholders or considering the organization's specific operational context, would also be flawed. Effective implementation requires buy-in and understanding from all levels of the organization, and the system must be tailored to the unique risks and impacts of the company's activities. A generic, top-down implementation is unlikely to be sustainable or effective. The professional reasoning process for similar situations should involve a systematic review of the applicable international standard, ISO 14001, a comprehensive understanding of all relevant national and local regulations, U.S. environmental laws, OSHA standards, an assessment of the organization's specific operational context and risks, and the engagement of key stakeholders to ensure buy-in and effective implementation. The goal is to create an integrated system that is both compliant with legal mandates and aligned with best practices for environmental management. Question 9. Stakeholder feedback indicates that a Superfund site on the National Priorities List, NPL, is experiencing significant delays in its remedial action planning due to disagreements between the U.S. Environmental Protection Agency, EPA, the potentially responsible parties, PRP, and the local community regarding the scope and methodology of the cleanup. The local community is concerned about potential exposure pathways and long-term health impacts, while the PRPs are pushing for the most cost-effective solutions, even if they are less comprehensive. As the certified safety professional, CSP, overseeing the project, which of the following approaches best aligns with regulatory requirements and professional best practices for addressing this complex situation? Option A. Dismiss the local community's concerns as primarily emotional and focus solely on the technical aspects of the cleanup as directed by the EPA, assuming their input is not critical to the regulatory process. Option B. Focus on negotiating a settlement with the potentially responsible parties for a limited scope of work that addresses their primary cost concerns, while assuring the local community that all necessary steps are being taken to protect their immediate health. Option C. Prioritize the development of a Remedial Action Work Plan, RAWP, that incorporates a thorough risk assessment, considers all technically viable cleanup alternatives that meet CERCLA cleanup standards and ARAR, and includes a robust plan for public engagement and comment on the proposed actions, ensuring all stakeholder concerns are formally addressed. Option D. Advise the EPA to proceed with a simplified cleanup plan based on the cheapest available technologies, as this will expedite the process and satisfy the immediate financial pressures of the responsible parties. Correct answer is C. Prioritize the development of a remedial action work plan, RAWP, that incorporates a thorough risk assessment, considers all technically viable cleanup alternatives that meet CERCLA cleanup standards and ARAR, and includes a robust plan for public engagement and comment on the proposed actions, ensuring all stakeholder concerns are formally addressed. Explanation. This scenario is professionally challenging because it requires balancing competing stakeholder interests and adhering to complex regulatory requirements under the Comprehensive Environmental Response, Compensation and Liability Act, CERCLA, concerning sites on the National Priorities List, NPL. The certified safety professional, CSP, must navigate the legal obligations of CERCLA while also addressing the legitimate concerns of the local community and the responsible parties. The NPL designation signifies a site with significant environmental contamination requiring federal attention, and the CSP's role is to ensure that response actions are protective of human health and the environment, consistent with CERCLA mandates. The correct approach represents best professional practice because it prioritizes a thorough, data-driven risk assessment and the development of a remedial action work plan, RAWP, that is compliant with CERCLA and its implementing regulations, such as those found in the National Contingency Plan, NCP. This approach ensures that the proposed cleanup activities are technically sound, cost-effective, and meet the cleanup standards established for the site. Engaging with all stakeholders, including the community and responsible parties, through formal comment periods and public meetings as mandated by CERCLA, is crucial for transparency and to build consensus, thereby minimizing future disputes and ensuring the long-term success of the cleanup. This aligns with the CSP's ethical obligation to protect public health and safety and the environment. An incorrect approach that focuses solely on the immediate demands of the responsible parties without a comprehensive risk assessment fails to meet CERCLA requirement for a thorough evaluation of the site's hazards and the development of appropriate remedial strategies. This could lead to an inadequate cleanup, potentially leaving residual contamination that poses a risk to human health and the environment, a direct violation of CERCLA objectives. Ethically, this approach prioritizes cost saving over safety and environmental protection. Another incorrect approach that dismisses community concerns as purely emotional or political, without engaging in meaningful dialogue or addressing their valid questions about potential health impacts and site safety, is a significant regulatory and ethical failure. CERCLA explicitly mandates public participation and input. Ignoring these concerns undermines the public trust and can lead to legal challenges and project delays, ultimately hindering the cleanup process. This demonstrates a lack of professional judgment and a failure to uphold the CSP's responsibility to communicate effectively with all affected parties. A third incorrect approach that prioritizes the cheapest available cleanup technology without considering its effectiveness in meeting the established cleanup standards or its long-term protectiveness is also professionally unacceptable. CERCLA requires that remedial actions be protective of human health and the environment and meet applicable or relevant and appropriate requirements ARAR. Selecting a remedy based solely on cost without this due diligence risks noncompliance with CERCLA and can result in an ineffective cleanup, necessitating further costly actions later. The professional decision-making process for similar situations involves a systematic approach. First, thoroughly understanding the regulatory framework, CERCLA and NCP. Second, conducting a comprehensive site assessment and risk evaluation. Third, developing technically sound and legally compliant remedial alternatives. Fourth, engaging all stakeholders transparently and inclusively. And fifth, documenting all decisions and actions meticulously. This process ensures that decisions are informed, defensible, and aligned with the CSP's professional responsibilities and ethical obligations. Question 10. Quality control measures reveal that an underground storage tank system at a facility is exhibiting intermittent readings from its leak detection system, suggesting a potential issue. The facility manager is concerned about operational downtime and potential costs associated with repairs. Which of the following actions best represents a professional and compliant approach to address this situation? Option A. Focus solely on identifying the least expensive repair option for the leak detection system, deferring any assessment of the USD's structural integrity until a confirmed leak is detected. Option B. Immediately initiate a comprehensive investigation into the leak detection system's performance and the integrity of the USD, following all applicable regulatory protocols for suspected leaks or system malfunctions, and document all findings and corrective actions. Option C. Temporarily disable the intermittent leak detection system and schedule a review of its functionality for the next scheduled maintenance cycle to avoid immediate operational disruption. Option D. Implement a minor adjustment to the leak detection system's sensitivity settings to see if the intermittent readings cease without further investigation into the tank's integrity. The correct answer is B. Immediately initiate a comprehensive investigation into the leak detection system's performance and the integrity of the USD, following all applicable regulatory protocols for suspected leaks or system malfunctions, and document all findings and corrective actions. Explanation. This scenario presents a common implementation challenge in environmental safety management, specifically concerning underground storage tanks, UST. The professional challenge lies in balancing immediate operational needs with long-term regulatory compliance and environmental protection. A safety professional must exercise careful judgment to ensure that any corrective actions taken are both effective and legally sound, preventing potential environmental contamination and associated liabilities. The correct approach represents best professional practice because it directly addresses the identified deficiency in a manner that aligns with the spirit and letter of regulatory requirements for USD systems. This approach prioritizes a thorough, documented investigation to understand the root cause of the quality control findings, followed by a systematic and compliant repair or replacement strategy. This ensures that the USD system is brought back into full compliance, minimizing the risk of future leaks and environmental harm, and fulfilling the professional's ethical obligation to protect public health and the environment. An incorrect approach that bypasses proper investigation and documentation is professionally unacceptable. It represents a failure to adhere to regulatory mandates that often require specific procedures for addressing USD deficiencies, including leak detection, reporting, and repair protocols. Ethically, it demonstrates a disregard for due diligence and a potential willingness to overlook or conceal noncompliance, which can lead to significant environmental damage, legal penalties, and reputational harm. Another incorrect approach that focuses solely on superficial fixes without addressing the underlying issue is also professionally unsound. This approach fails to meet the intent of regulations, which aim to ensure the integrity and safety of USD systems. It may provide a temporary appearance of compliance, but leaves the system vulnerable to future failures, thereby failing to adequately protect the environment and public safety. This can be seen as a form of negligence. A third incorrect approach that prioritizes cost savings over regulatory compliance and environmental protection is ethically and professionally flawed. While cost-effectiveness is a consideration, it must never supersede the legal and ethical obligations to maintain safe and compliant USD systems. This approach demonstrates poor professional judgment and a lack of commitment to the core principles of environmental safety. The professional reasoning process for similar situations should involve 1. Thoroughly understanding the specific regulatory requirements applicable to USDs in the relevant jurisdiction, e.g., EPA regulations in the U.S. 2. Investigating any identified issues with a systematic and documented approach to determine the root cause. 3. Developing a corrective action plan that is compliant with all applicable regulations and best practices. 4. Documenting all findings, actions, and communications meticulously. 5. Communicating effectively with stakeholders, including management and regulatory agencies, as required. 6. Prioritizing environmental protection and public safety in all decision-making. Question 11. Which approach would be most effective in ensuring compliance and worker safety when a facility identifies a new area that may qualify as a permit-required confined space? Option A. Rely on the experience of long-term employees who have previously worked in similar areas to determine if a permit is necessary. Option B. Conduct a quick walkthrough to gauge the general atmosphere, and then proceed with entry if no obvious immediate dangers are apparent. Option C. Immediately initiate a comprehensive hazard assessment, develop a detailed entry permit, and implement all necessary control measures and training protocols before allowing any entry. Option D. Assume the space is safe for entry if it has not presented any issues in the past, and proceed with entry after a brief visual inspection. The correct answer is C. Immediately initiate a comprehensive hazard assessment, develop a detailed entry permit, and implement all necessary control measures and training protocols before allowing any entry. Explanation: this scenario is professionally challenging because it requires a safety professional to balance the immediate need for access to a confined space with the paramount importance of ensuring worker safety. The decision-making process must be grounded in established regulatory frameworks and best practices to prevent serious injury or fatality. The core challenge lies in accurately assessing the risks associated with the confined space and implementing appropriate controls before entry. The correct approach represents best professional practice because it prioritizes a systematic, risk-based methodology that aligns with the intent of regulatory requirements, such as those found in OSHA Permit-Required Confined Spaces Standard 29 CFR 1910-146. This approach involves a thorough hazard assessment, development of a comprehensive permit system, implementation of engineering and administrative controls, provision of appropriate personal protective equipment, and robust training for all involved personnel. This ensures that all potential hazards are identified, evaluated, and controlled before any entry occurs, thereby minimizing the likelihood of incidents. An incorrect approach that bypasses or inadequately addresses the hazard assessment and permit requirements is professionally unacceptable. This failure constitutes a direct violation of regulatory mandates designed to protect workers. Ethically, it represents a dereliction of duty by the safety professional, as it knowingly exposes employees to potentially fatal hazards. Another incorrect approach that relies solely on the experience of the entrant without formal procedures or documentation ignores the systemic nature of confined space safety and the need for verifiable controls. This is a regulatory failure because it lacks the documented evidence of hazard evaluation and control measures required by law. A third incorrect approach that assumes a space is safe based on past entries without reevaluation is also a significant failure. Confined space conditions can change rapidly, and a lack of reassessment is a direct violation of the principle of continuous risk management and regulatory requirements for reevaluation. Professionals should employ a decision-making framework that begins with a clear understanding of the regulatory definition of a permit-required confined space. This framework involves 1. Identifying potential permit-required confined spaces. 2. Conducting a thorough hazard assessment for each identified space, considering atmospheric, physical, chemical, and biological hazards. 3. Determining if the space meets the criteria for a permit-required confined space. 4. If it does, developing and implementing a written permit program that includes hazard identification, control measures, attendant duties, rescue procedures, and authorized entrant training. 5. Ensuring all controls are in place and verified before issuing a permit. 6. Regularly reviewing and updating the program based on lessons learned and changes in conditions. Question 12. The review process indicates that a manufacturing facility utilizes several refrigerants and fire suppression agents that are known to be ozone-depleting substances (ODS) under the Montreal Protocol. The company is seeking guidance on how to proceed with managing these substances to ensure compliance and minimize environmental impact. Which of the following represents the most appropriate course of action for the safety professional to recommend? Option A. Replace the ODS with readily available, less expensive chemical alternatives, without conducting a thorough assessment of their own environmental profiles or potential future regulatory status. Option B. Continue using the existing ODS until a specific enforcement action or direct prohibition is issued by the local regulatory authority, as international agreements do not always translate directly into immediate local mandates. Option C. Assume that the company's specific manufacturing processes are covered by an exemption under the Montreal Protocol and continue current usage until such an exemption is formally revoked or challenged. Option D. Immediately initiate a comprehensive inventory of all ODS used, research and identify approved alternatives for each application, and develop a phased transition plan aligned with the Montreal Protocol's phase-out schedules and the jurisdiction's implementing regulations. The correct answer is D. Immediately initiate a comprehensive inventory of all ODS used, research and identify approved alternatives for each application, and develop a phased transition plan aligned with the Montreal Protocol's phase-out schedules and the jurisdiction's implementing regulations. Explanation: scenario analysis. This scenario is professionally challenging because it requires a safety professional to navigate complex international environmental regulations, specifically the Montreal Protocol, within the context of a company's operational decisions. The challenge lies in balancing economic pressures with the imperative to comply with legally binding international agreements designed to protect global health and the environment. Misinterpreting or ignoring these obligations can lead to significant legal penalties, reputational damage, and most importantly, continued environmental harm. Correct approach analysis. The correct approach involves proactively identifying and phasing out the use of ozone-depleting substances, ODS, in accordance with the Montreal Protocol's established phase-out schedules and the specific regulations of the jurisdiction, assumed to be a signatory nation to the protocol. This demonstrates best professional practice by prioritizing environmental stewardship and regulatory compliance. It aligns with the ethical responsibility of a safety professional to protect human health and the environment. Adhering to the protocol's guidelines ensures that the company's actions contribute to the global effort to repair the ozone layer, preventing increased UV radiation exposure and its associated health risks. This proactive stance also mitigates future compliance risks and potential liabilities. Incorrect approaches analysis. One incorrect approach involves continuing to use ODS until a specific regulatory mandate in the company's immediate jurisdiction explicitly prohibits their use, regardless of international phase-out timelines. This is a failure to adhere to the spirit and intent of the Montreal Protocol, which aims for a global, coordinated phase-out. It represents a reactive, rather than proactive safety and environmental management strategy, potentially exposing the company to future regulatory changes and international pressure. Ethically, it prioritizes short-term convenience over long-term global well-being. Another incorrect approach is to replace ODS with substances that are not yet fully assessed for their long-term environmental impact or potential to be regulated under future international agreements. Seemingly a solution, this approach risks creating new environmental problems or facing future compliance challenges if these replacement substances are later found to be harmful or are also phased out. It demonstrates a lack of thorough due diligence and a failure to consider the broader environmental implications beyond immediate ODS replacement. A third incorrect approach is to argue that the company's specific industry sector is exempt from the Montreal Protocol's requirements, without verifying this claim against the protocol's annexes and the implementing regulations of the relevant jurisdiction. Such an assumption, if unfounded, constitutes a direct violation of the protocol and its associated laws. It reflects a lack of commitment to understanding and complying with environmental obligations and could lead to severe legal repercussions. Professional reasoning. When faced with decisions involving international environmental agreements like the Montreal Protocol, safety professionals must adopt a proactive and informed approach. The decision-making process should involve 1. Thoroughly understanding the specific obligations imposed by the Montreal Protocol and its amendments, as well as the implementing legislation in their jurisdiction. 2. Identifying all substances used within the organization that are classified as ODS. 3. Developing and implementing a phase-out plan that aligns with the protocol's established timelines, prioritizing the use of environmentally sound alternatives. 4. Regularly reviewing and updating compliance strategies in light of evolving scientific understanding and regulatory updates. 5. Engaging with relevant stakeholders, including regulatory bodies and industry associations, to ensure accurate interpretation and implementation of requirements. This systematic approach ensures both legal compliance and responsible environmental stewardship. Question 13. The analysis reveals that a certified safety professional (CSP) in the United States is tasked with developing workplace safety protocols in response to fluctuating air quality index (AQI) levels. Given an AQI reading of unhealthy for sensitive groups due to elevated levels of fine particulate matter, PM2.5. Which of the following actions best aligns with U.S. regulatory frameworks and professional best practices for protecting worker health? Option A. Advise employees to stay indoors and avoid strenuous activity, but allow operations to continue as normal as the AQI is not yet in the unhealthy category for the general population. Option B. Recommend a temporary suspension of all outdoor work and encourage employees to wear basic dust masks if they must be in affected areas, while awaiting further AQI changes. Option C. Implement enhanced ventilation systems and provide N95 respirators to all employees working outdoors or in areas with potential for high exposure, while continuing normal operations. Option D. Focus solely on ensuring that any specific OSHA permissible exposure limits, PEL, for particulate matter are not exceeded, as the AQI is a public health metric and not a direct workplace standard. Correct answer is C. Implement enhanced ventilation systems and provide N95 respirators to all employees working outdoors or in areas with potential for high exposure, while continuing normal operations. Explanation. The analysis reveals a common challenge for certified safety professionals, CSP in the United States, interpreting and applying the Air Quality Index, AQI, for workplace safety decisions, particularly when dealing with varying levels of public health advisories. The professional challenge lies in translating complex environmental data into actionable safety protocols that protect workers, while also considering operational realities and regulatory compliance. This requires a nuanced understanding beyond simply knowing the AQI numbers. It involves understanding the underlying health impacts and the appropriate responses mandated or recommended by relevant U.S. regulatory bodies. The correct approach represents best professional practice because it directly aligns with the Occupational Safety and Health Administration's OSHA General Duty Clause, which requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. When the AQI indicates unhealthy or hazardous conditions, this constitutes a recognized hazard. A CSP's responsibility is to assess the specific pollutants contributing to the AQI, understand their health effects, and implement controls that mitigate worker exposure, such as enhanced ventilation, respiratory protection, or even temporary work stoppages, as dictated by the severity of the AQI and the nature of the work. This proactive, risk-based approach, informed by the AQI and its implications for worker health, is ethically sound and legally defensible under U.S. regulations. An incorrect approach that focuses solely on the numerical AQI value without considering the specific pollutants and their health impacts is a regulatory failure. For instance, a high AQI driven by ozone might require different controls than a high AQI driven by fine particulate matter, PM2.5, even if the numerical index is the same. This demonstrates a lack of deep understanding of the hazard. Another incorrect approach, such as ignoring AQI advisories altogether because they are not explicitly listed as a permissible exposure limit, PEL, for every pollutant, is an ethical and regulatory failure. OSHA General Duty Clause necessitates action for recognized hazards, even if specific PELs are not exceeded or applicable. Relying solely on general public health guidance without a site-specific risk assessment also represents a failure to adequately protect workers, as it doesn't account for the unique exposure scenarios within a particular workplace. The professional reasoning process for similar situations should involve 1. Monitoring relevant AQI data for the workplace location. 2. Understanding the specific pollutants contributing to the AQI and their associated health risks. 3. Consulting OSHA standards and guidance, as well as any applicable state or local regulations. 4. Conducting a site-specific risk assessment to determine potential worker exposure levels and the effectiveness of existing controls. 5. Implementing appropriate engineering controls, administrative controls, and personal protective equipment, PPE, based on the risk assessment and AQI severity. 6. Communicating risks and protective measures clearly to employees. 7. Documenting all assessments, decisions, and implemented controls. Question 14. The risk matrix shows a low probability of immediate, severe environmental damage from the proposed waste disposal method, but a high probability of long-term, low-level soil and groundwater contamination if not managed meticulously. Management is pushing for the least expensive disposal option, which aligns with the low probability, low impact assessment on the matrix. But your professional judgment suggests this method is inherently less protective of the environment over time. What is the most ethically and professionally responsible course of action? Option A. Proceed with the least expensive disposal option as directed by management, assuming that any future contamination will be a separate issue to be addressed if and when it arises. Option B. Advocate for a more robust, albeit more expensive, waste disposal method that has a proven track record of minimizing long-term environmental impact, even if the immediate risk assessment on the matrix appears low. Option C. Recommend the least expensive disposal option, documenting the low immediate risk shown on the matrix, and advise management that further environmental monitoring will be necessary to detect any long-term issues. Option D. Request a detailed cost-benefit analysis from management that quantifies the potential future costs of environmental remediation versus the immediate savings from the cheaper disposal method, and use this to inform your recommendation. Correct answer is C. Recommend the least expensive disposal option, documenting the low immediate risk shown on the matrix, and advise management that further environmental monitoring will be necessary to detect any long-term issues. Explanation. This scenario presents a professional challenge due to the conflict between immediate cost savings and long-term environmental stewardship, which is a core ethical responsibility for certified safety professionals. The pressure to reduce expenses can create a temptation to overlook or downplay potential environmental risks, especially when the consequences are not immediately apparent or directly attributable to the company. Careful judgment is required to balance economic realities with the imperative to protect the environment and comply with regulations. The correct approach represents best professional practice because it prioritizes a thorough, science-based assessment of environmental risks and proactive mitigation strategies, aligning with the principles of responsible environmental management and regulatory compliance. This approach demonstrates a commitment to the public trust and the long-term sustainability of the organization and its surrounding ecosystem. It reflects a proactive stance, anticipating potential issues before they escalate into significant environmental damage or regulatory violations. An incorrect approach that focuses solely on the immediate cost savings without a comprehensive environmental impact assessment fails to uphold the ethical duty of a safety professional to protect both human health and the environment. This approach risks violating environmental regulations, such as those under the EPA's purview in the U.S., which mandate responsible waste management and pollution prevention. It also represents an ethical failure by prioritizing short-term financial gain over environmental well-being and potentially exposing the company to future liabilities, reputational damage, and legal penalties. Another incorrect approach that involves delaying the investigation into potential contamination until a formal complaint is received is also professionally unacceptable. This reactive stance ignores the proactive principles of environmental management and the potential for ongoing environmental degradation. It can lead to more severe and costly remediation efforts if contamination spreads or impacts sensitive ecological areas. Ethically, it demonstrates a lack of due diligence and a disregard for the precautionary principle, which suggests taking preventive action in the face of potential harm even with scientific uncertainty. The professional decision-making process for similar situations should involve 1. Identifying the ethical and regulatory obligations related to environmental protection. 2. Conducting a comprehensive risk assessment that includes potential environmental impacts, even if not immediately obvious. 3. Evaluating all available data and expert opinions to understand the scope and severity of potential risks. 4. Developing and implementing a mitigation plan that addresses identified risks, considering both short-term and long-term consequences. 5. Communicating findings and recommendations clearly to management, emphasizing both the risks of inaction and the benefits of proactive measures. 6. Documenting all assessments, decisions, and actions taken. Question 15. Stakeholder feedback indicates that a multinational corporation is facing increasing scrutiny regarding its environmental impact across its global operations. The company's environmental management system needs to be updated to reflect current international environmental regulations and conventions. Which of the following approaches best ensures comprehensive compliance and responsible environmental stewardship? Option A. Focus exclusively on national regulations that carry the most significant financial penalties for non-compliance, as these represent the highest immediate risk. Option B. Adopt a strategy of complying only with the minimum requirements of the oldest, most established international environmental agreements, as these are generally well understood and less likely to change. Option C. Prioritize adherence to the most recently ratified international environmental conventions and their most stringent national implementations, while also considering emerging best practices and voluntary industry standards. Option D. Rely on the company's historical environmental compliance record and assume that existing practices meet current international standards unless explicitly challenged. The correct answer is C. Prioritize adherence to the most recently ratified international environmental conventions and their most stringent national implementations, while also considering emerging best practices and voluntary industry standards. Explanation: this scenario presents a professional challenge due to the inherent complexity of navigating international environmental regulations, which often have overlapping mandates, varying enforcement mechanisms, and differing levels of stringency. A safety professional must exercise careful judgment to ensure compliance and protect both human health and the environment, while also considering the economic and operational implications for the organization. The challenge is amplified when dealing with a multinational corporation operating across diverse regulatory landscapes. The correct approach represents best professional practice because it prioritizes a systematic and comprehensive review of all applicable international environmental agreements and national implementations. This ensures that the organization's environmental management system is robust, up-to-date, and aligned with the highest standards of environmental protection, adhering to the spirit and letter of conventions like the Stockholm Convention on Persistent Organic Pollutants, POP, or the Minamata Convention on Mercury, and their respective national legislations, demonstrates a commitment to responsible corporate citizenship and proactive risk management. This approach is ethically sound, as it prioritizes the prevention of environmental harm and the protection of vulnerable populations, aligning with professional codes of conduct for safety professionals. An incorrect approach that focuses solely on the most lenient regulations fails to meet the ethical and professional obligation to protect the environment and human health. It risks significant legal penalties, reputational damage, and potential harm to ecosystems and communities. This approach demonstrates a lack of due diligence and a disregard for the principles of environmental stewardship. Another incorrect approach that relies on outdated or superseded international agreements is equally problematic. Environmental science and international consensus evolve, and failing to stay current with these developments can lead to non-compliance with current standards and best practices. This reflects poor professional judgment and a failure to maintain necessary expertise. A third incorrect approach that only considers regulations where direct penalties are explicitly stated overlooks the broader implications of environmental noncompliance. Many international environmental agreements have reporting requirements, review mechanisms, and can influence trade agreements or access to markets. Furthermore, ethical considerations and stakeholder expectations extend beyond legally mandated penalties. This approach is short-sighted and fails to account for the full spectrum of risks and responsibilities. The professional decision-making process for similar situations should involve a multi-step approach. 1. Identify all relevant international environmental conventions and agreements that pertain to the organization's operations, products, or services. 2. Research and understand the specific requirements and obligations stipulated by these conventions. 3. Investigate how each convention has been implemented into national legislation in all relevant jurisdictions where the organization operates. 4. Conduct a gap analysis to identify any discrepancies between the organization's current practices and the requirements of the applicable international and national regulations. 5. Prioritize actions based on the severity of potential environmental and health impacts, legal risks, and stakeholder expectations. 6. Develop and implement a comprehensive environmental management system that ensures ongoing compliance and continuous improvement. 7. Regularly review and update the environmental management system to reflect changes in international agreements, national laws, and scientific understanding. 8. Engage with stakeholders to understand their concerns and expectations regarding environmental performance. Question 16. During the evaluation of a new chemical manufacturing facility safety management system, what is the most effective approach for a certified safety professional to integrate the consideration of ecosystem services into the hazard identification and risk assessment process, particularly when these services might indirectly influence worker or community safety? Option A. Exclude ecosystem services from the safety assessment, as they are primarily an environmental concern and not directly related to occupational safety regulations. Option B. Assign a precise monetary value to each ecosystem service and use this to justify the cost-effectiveness of proposed safety controls. Option C. Delegate the entire assessment and management of ecosystem services to the Environmental Compliance Department with no direct involvement from the safety team. Option D. Systematically identify relevant ecosystem services, assess their potential degradation from facility operations, and incorporate protective measures into the overall safety plan, recognizing their indirect impact on hazard potential. The correct answer is D. Systematically identify relevant ecosystem services, assess their potential degradation from facility operations, and incorporate protective measures into the overall safety plan, recognizing their indirect impact on hazard potential. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a certified safety professional, CSP, to integrate the often abstract concept of ecosystem services into a tangible risk assessment and mitigation plan. The difficulty lies in quantifying or qualitatively assessing the value and impact of ecosystem services, which are not always directly tied to traditional safety metrics like injury rates or property damage. Furthermore, the CSP must navigate potential conflicts between immediate operational safety needs and the long-term sustainability benefits derived from ecosystem services, demanding a holistic and forward-thinking approach. The regulatory framework for CSPs, particularly within the U.S. context, emphasizes a proactive and comprehensive approach to hazard identification and control, which extends beyond immediate human safety to encompass environmental stewardship where it directly or indirectly impacts worker or community well-being. Correct approach analysis. The correct approach involves systematically identifying ecosystem services relevant to the facility's operations and surrounding environment, assessing their potential degradation due to operational activities, and then developing control measures that not only mitigate direct safety hazards, but also protect or enhance these services. This aligns with best professional practice as outlined by the Board of Certified Safety Professionals, BCSP, which encourages a broad understanding of risk, including environmental factors that can influence safety. Specifically, the Occupational Safety and Health Act (OSHA) General Duty Clause 29 U.S.C. 654 A.1 mandates employers provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm to employees. While not explicitly mentioning ecosystem services, the degradation of these services, e.g., loss of natural flood control leading to inundation of facilities, or air quality degradation impacting respiratory health, can directly or indirectly create such recognized hazards. Therefore, protecting ecosystem services is a proactive measure to prevent potential safety incidents and ensure a safe working environment. Ethical considerations also support this approach, as responsible professionals are expected to consider the broader impact of their work on the environment and community. Incorrect approach is analysis. One incorrect approach is to solely focus on direct, immediate safety hazards and disregard any potential impacts on ecosystem services, arguing that they fall outside the direct purview of occupational safety. This fails to recognize that environmental degradation can create indirect safety hazards, violating the spirit and intent of the General Duty Clause and broader risk management principles. It represents a failure to conduct a comprehensive hazard analysis. Another incorrect approach is to attempt to assign a precise monetary value to each ecosystem service and incorporate it into a cost-benefit analysis for safety controls. While economic valuation can be a tool, the complexity and inherent uncertainties in valuing ecosystem services can lead to paralysis or inaccurate decision-making, diverting focus from the primary safety objective. This approach may also be overly reductionist, failing to capture the qualitative and intrinsic value of these services, and could lead to regulatory noncompliance, if it results in the prioritization of economic factors over demonstrable safety needs. A third incorrect approach is to delegate the entire responsibility for ecosystem service assessment and management to an environmental department without any integration into the safety management system. This creates a siloed approach to risk management, preventing a holistic understanding of how environmental factors can influence safety and vice versa. It is a failure of professional responsibility to ensure all relevant hazards, including those indirectly caused by environmental factors, are addressed. Professional reasoning. Professionals should adopt a systematic, integrated risk management framework. This involves 1. Broadening the scope of hazard identification to include environmental factors that could indirectly impact safety. 2. Conducting a qualitative or semi-quantitative assessment of the significance of identified ecosystem services and their potential degradation. 3. Prioritizing control measures based on the hierarchy of controls, considering both direct safety risks and the protection of ecosystem services. 4. Collaborating with environmental specialists and other stakeholders to ensure a comprehensive understanding and effective mitigation strategy. 5. Documenting the rationale for decisions, demonstrating due diligence and adherence to professional standards and regulatory requirements. Question 17. The efficiency study reveals that current hazardous substance inventory reporting and emergency planning communication protocols are not optimally leveraging available data for community preparedness. Considering the requirements of the Emergency Planning and Community Right to Know Act (EPCRA), which of the following actions best addresses the study's findings from a stakeholder perspective? Option A. Focus on enhancing the technical infrastructure for data collection and analysis, assuming that improved internal data management will naturally lead to better community preparedness without direct external outreach. Option B. Conduct a detailed internal review of the study's findings to determine which data points are most critical for internal risk management before considering any external communication. Option C. Immediately update internal hazardous substance inventory databases to reflect the efficiency study's recommendations, and await a specific incident to trigger external communication of relevant hazard information. Option D. Develop a comprehensive plan to proactively disseminate the study's findings and relevant hazardous substance information to local emergency planning committees, community groups, and the public through accessible channels, and integrate this information into ongoing emergency response training. The correct answer is D. Develop a comprehensive plan to proactively disseminate the study's findings and relevant hazardous substance information to local emergency planning committees, community groups, and the public through accessible channels, and integrate this information into ongoing emergency response training. Explanation. This scenario presents a professional challenge because it requires balancing regulatory compliance with effective community engagement and resource allocation. The Certified Safety Professional, CSP, must interpret the implications of the efficiency study's findings within the framework of the Emergency Planning and Community Right to Know Act (EPCRA), and translate these findings into actionable strategies that protect public health and safety, while also considering the practicalities of implementation. The challenge lies in moving beyond a purely compliance-driven mindset to one that fosters proactive risk reduction and robust stakeholder relationships. The correct approach represents best professional practice because it directly addresses the core intent of EPCRA: to empower communities with information about hazardous substances and to facilitate coordinated emergency planning. By prioritizing the development of a comprehensive and accessible public information dissemination plan based on the study's findings, the CSB demonstrates a commitment to transparency and community preparedness. This aligns with EPCRA goals of informing the public and local emergency responders about potential hazards, enabling them to develop effective response strategies. Furthermore, it fosters trust and collaboration with community stakeholders, which is crucial for successful emergency management. An incorrect approach that focuses solely on internal reporting without a clear plan for external communication fails to meet EPCRA mandate for public disclosure. This oversight can lead to a lack of awareness among community members and emergency responders, hindering their ability to prepare for or respond to incidents involving hazardous substances. Ethically, this approach prioritizes administrative convenience over public safety and the right to know. Another incorrect approach that involves delaying the dissemination of information until a specific incident occurs is a critical regulatory and ethical failure. EPCRA requires proactive information sharing, not reactive disclosure. This delay undermines the purpose of emergency planning and can have severe consequences during an actual event, as communities and responders will be ill-equipped to handle the situation. It also violates the spirit of transparency and preparedness that EPCRA is designed to foster. A third incorrect approach that involves selectively sharing information based on perceived community interest or understanding risks, excluding vital stakeholders, and potentially creating information gaps. This selective approach is not only a regulatory failure, but also an ethical one, as it can lead to disproportionate impacts on certain segments of the community and erode trust. Effective emergency planning requires comprehensive and equitable information sharing. A professional decision-making process for similar situations should involve a thorough understanding of EPCRA requirements, including reporting thresholds, information dissemination mandates, and emergency planning committee roles. Professionals should then analyze the findings of any relevant studies, such as the efficiency study mentioned, to identify potential impacts on community safety and preparedness. This analysis should be followed by the development of a clear, actionable plan that prioritizes transparency, stakeholder engagement, and proactive risk mitigation, ensuring compliance with all applicable regulations and upholding ethical obligations to protect public health and safety. Question 18. Process analysis reveals that a chemical manufacturing facility, operating for several years, is proposing to modify its wastewater treatment discharge system. The existing system discharges treated effluent into a designated wetland area adjacent to the facility. While the facility holds a valid National Pollutant Discharge Elimination System (NPDES) permit under Section 402 of the Clean Water Act, which sets effluent limitations for the discharge, the proposed modification involves a change in the discharge point and an increase in the volume of treated water. The facility's environmental manager is concerned about potential violations of Section 404 of the Clean Water Act, which regulates the discharge of dredged or fill material into waters of the United States, including wetlands. The manager needs to determine the appropriate course of action regarding Section 404 compliance for these ongoing operational activities. Which of the following represents the most appropriate and legally compliant approach for the environmental manager to take? Option A. Focus solely on ensuring the modified discharge meets the existing NPDES permit effluent limitations, as this is the primary regulatory concern for operational discharges. Option B. Consult with Environmental Legal Counsel and the U.S. Army Corps of Engineers to clarify whether the proposed operational discharge and associated activities constitute a regulated discharge of dredged or fill material under Section 404, and to determine if a permit is required. Option C. Assume that since the facility has an NPDES permit and the discharge is treated, Section 404 is not applicable to ongoing operational modifications. Option D. Immediately proceed with the discharge system modification, as it is an operational change and not related to initial construction, and therefore outside the scope of Section 404. The correct answer is C. Assume that since the facility has an NPDES permit and the discharge is treated, Section 404 is not applicable to ongoing operational modifications. Explanation. Scenario analysis. This scenario presents a common challenge in environmental safety management, where a project's operational needs appear to conflict with regulatory requirements. A professional's task is to balance the economic and functional demands of the facility with the legal obligations to protect wetlands, which are ecologically sensitive and legally defined areas. The challenge lies in interpreting the scope of discharges under Section 404 of the Clean Water Act and determining if the proposed operational activities constitute a regulated discharge, even if not directly related to initial construction. Misinterpreting these regulations can lead to significant legal penalties, environmental damage, and reputational harm. Correct approach analysis. The correct approach involves a thorough review of the project's current operational activities against the definitions and exemptions within Section 404 of the Clean Water Act and its implementing regulations, 33 CFR Part 323. Specifically, it requires determining if the routine discharge of treated wastewater, even if meeting certain effluent standards, is considered a discharge of dredged or fill material, or if it falls under an exemption or a different regulatory program, e.g., NPDES permits under Section 402. Consulting with environmental legal counsel and the relevant regulatory agency, e.g., the U.S. Army Corps of Engineers and the U.S. Environmental Protection Agency, to clarify the applicability of Section 404 to ongoing operations is the most prudent and legally sound course of action. This proactive engagement ensures compliance and avoids potential violations. Incorrect approach is analysis. One incorrect approach is to assume that because the facility has been operating for a period and the discharge meets effluent standards, it is automatically exempt from Section 404 review for ongoing operations. This fails to recognize that Section 404 regulates the discharge of dredged or fill material into waters of the United States and ongoing operational discharges, if they involve such material or alter the physical condition of a wetland, may still be subject to permitting requirements. Relying solely on effluent standards for NPDES permits does not negate potential Section 404 obligations. Another incorrect approach is to proceed with the operational changes without any regulatory consultation, assuming that the discharge is solely an NPDES matter. This ignores the distinct purpose of Section 404, which is to regulate the physical alteration of wetlands and other waters of the U.S. through the discharge of dredged or fill material. If the operational discharge, or the associated infrastructure, involves such material or impacts the wetland's physical characteristics, it could be a Section 404 violation regardless of NPDES compliance. A third incorrect approach is to dismiss the concern based on the fact that the discharge is treated. While treatment can be a factor in regulatory decisions, it does not automatically exempt a discharge from Section 404 review if the discharge itself constitutes dredged or fill material, or if the activity associated with the discharge physically alters a wetland. The nature of the material discharged and its impact on the wetland's physical structure are key considerations under Section 404. Professional reasoning. Professionals in this situation should employ a risk-based, compliance-first decision-making framework. This involves 1. Identifying potential regulatory triggers based on project activities and environmental impacts. 2. Conducting a thorough review of applicable regulations, including specific definitions and exemptions. 3. Seeking expert advice, legal and technical, when ambiguity exists. 4. Engaging proactively with regulatory agencies to clarify requirements and ensure compliance. 5. Documenting all assessments, decisions, and communications. This systematic approach minimizes legal and environmental risks and upholds professional responsibility. Question 19. Regulatory review indicates that a company plans to export a consignment of hazardous waste for disposal. The proposed disposal facility in the receiving country is significantly cheaper than options within the country of origin, but the notification and consent procedures required by the Basel Convention appear to be more complex and time-consuming for this particular route. The company's management is pressuring for the quickest and most cost-effective solution. As the certified safety professional overseeing this operation, what is the most appropriate course of action? Option A. Inform management that the Basel Convention's requirements for notification, consent, and tracking must be fully adhered to, regardless of the time and cost implications, and propose alternative disposal methods if compliance cannot be achieved with the current plan. Option B. Initiate the export process immediately and address any potential Basel Convention compliance issues retroactively once the waste has been shipped, prioritizing the company's immediate operational needs. Option C. Reclassify the waste to a less hazardous category to simplify the export process and reduce associated costs, assuming the actual environmental risk is minimal. Option D. Proceed with the export to the cheaper facility, ensuring all documentation is completed to the best of the company's ability, even if some procedural steps are expedited or simplified to meet the deadline and cost targets. The correct answer is D. Proceed with the export to the cheaper facility, ensuring all documentation is completed to the best of the company's ability, even if some procedural steps are expedited or simplified to meet the deadline and cost targets. Explanation. This scenario presents a professional challenge due to the inherent conflict between immediate cost-saving pressures and the long-term environmental and legal obligations mandated by the Basel Convention. A certified safety professional, CSP, must navigate this ethical and regulatory tightrope, prioritizing compliance and responsible waste management over short-term financial gains. The correct approach demonstrates best professional practice by adhering strictly to the Basel Convention's principles of transboundary movement of hazardous wastes and their disposal. This involves ensuring proper notification, consent, and tracking mechanisms are in place, even if it incurs higher initial costs. Ethically, this aligns with the CSB's duty to protect human health and the environment. Legally, it prevents violations of international and national regulations implementing the convention, avoiding severe penalties, reputational damage, and potential environmental harm. An incorrect approach that prioritizes a cheaper, less regulated disposal route fails to acknowledge the Basel Convention's intent to minimize hazardous waste generation and ensure environmentally sound management. This could lead to illegal dumping, improper treatment, or disposal in countries lacking adequate infrastructure, thereby violating the Convention's core objectives and potentially causing significant environmental contamination. Such an action would also breach the CSB's ethical obligation to uphold professional standards and legal requirements. Another incorrect approach might involve misclassifying the waste to avoid the Convention's stringent requirements. This is a direct violation of regulatory frameworks and constitutes fraudulent behavior. It undermines the entire purpose of hazardous waste regulation and exposes the company and the CSB to severe legal repercussions, including fines and criminal charges. A third incorrect approach could be to delay or ignore the notification and consent procedures, hoping to proceed without full scrutiny. This demonstrates a lack of due diligence and a disregard for the established international framework for managing hazardous waste. It creates a significant risk of non-compliance, as the transboundary movement would be unauthorized, leading to potential seizure of the waste, penalties, and diplomatic issues. The professional decision-making process for similar situations should involve a thorough understanding of the Basel Convention and its implementing regulations. CSB must proactively identify hazardous wastes, assess their classification, and understand the requirements for their management, including transboundary movement. When faced with cost pressures, the CSB should clearly articulate the regulatory obligations and the potential consequences of noncompliance to management. This involves presenting a risk assessment that quantifies not only financial risks, but also environmental and legal liabilities. The decision should always be guided by the principle of do no harm and adherence to the highest ethical and legal standards. Question 20. Governance review demonstrates that a municipal water system, regulated under the U.S. Safe Drinking Water Act, (SDWA), has historically focused its water quality testing and compliance efforts on lead and copper, as these were the primary concerns identified during initial system assessments. However, recent infrastructure upgrades and changes in the watershed's agricultural activity raise concerns about potential contamination from a broader range of substances. The Certified Safety Professional, CSB, responsible for overseeing the water system's safety and compliance, is tasked with ensuring adherence to all relevant water quality standards. Which of the following approaches best ensures the CSB's compliance with the SDWA and upholds professional safety standards? Option A. Continue to focus primary testing and compliance efforts on lead and copper, as these have been the historical contaminants of concern, and the system has a proven track record of compliance for these specific substances. Option B. Rely on historical testing data from the past 5 years to confirm that the water quality has remained within acceptable parameters, assuming that the recent infrastructure upgrades and watershed changes are unlikely to have introduced significant new contaminants. Option C. Conduct a comprehensive review of the Code of Federal Regulations, CFR, Title 40, Part 141, National Primary Drinking Water Regulations, to identify all regulated contaminants and their respective maximum contaminant levels, MCL, and treatment techniques. Based on this review, develop a revised testing and monitoring plan that addresses all identified contaminants, prioritizing those with the highest potential health risks and considering the recent changes in the watershed and infrastructure. Engage with the state's primacy agency to confirm any state-specific regulations that may be more stringent than federal requirements. Option D. Prioritize testing for contaminants that are known to be most cost-effective to treat if detected, ensuring that the water system remains financially viable while addressing potential water quality issues. The correct answer is C. Conduct a comprehensive review of the Code of Federal Regulations, CFR, Title 40, Part 141, National Primary Drinking Water Regulations, to identify all regulated contaminants and their respective maximum contaminant levels, MCL, and treatment techniques. Based on this review, develop a revised testing and monitoring plan that addresses all identified contaminants, prioritizing those with the highest potential health risks and considering the recent changes in the watershed and infrastructure. Engage with the state's primacy agency to confirm any state-specific regulations that may be more stringent than federal requirements. Explanation. This scenario presents a professional challenge because it requires the Certified Safety Professional, CSP, to interpret and apply complex water quality standards within a specific regulatory framework. The U.S. Environmental Protection Agency, EPA, regulations under the Safe Drinking Water Act, ESTWA. The challenge lies in identifying the most appropriate standard when multiple potential contaminants are present, and the organization's current practices may not align with the most stringent or relevant requirements. Careful judgment is required to ensure public health protection and regulatory compliance. The correct approach represents best professional practice because it prioritizes a comprehensive and proactive assessment of all potential contaminants against the most relevant EPA maximum contaminant levels, MCL, and treatment techniques. This aligns with the overarching goal of the ESTWA, which is to protect public health by regulating the nation's public drinking water supply. By consulting the Code of Federal Regulations, CFR, specifically Title 40, Part 141, the CSB can identify the legally enforceable standards for various contaminants. Furthermore, engaging with the state primacy agency ensures that any state-specific regulations, which may be more stringent than federal requirements, are also considered, demonstrating a commitment to exceeding minimum compliance. This approach is ethically sound, as it places public safety above expediency or cost-saving measures. An incorrect approach that focuses solely on the most frequently tested contaminant fails to acknowledge the possibility of other harmful substances being present and regulated. This is a regulatory failure because it overlooks potential violations of the ESTWA for other contaminants. Ethically, it is unacceptable as it creates a false sense of security and potentially exposes consumers to risks from unregulated contaminants. Another incorrect approach that relies on historical testing data without considering potential changes in the water source or treatment processes is also a regulatory and ethical failure. The ESTWA mandates ongoing monitoring and compliance, and historical data alone does not guarantee future compliance. Changes in environmental conditions, infrastructure, or source water can introduce new contaminants or increase the levels of existing ones, necessitating updated assessments. An approach that prioritizes cost-effectiveness over comprehensive compliance is fundamentally flawed. While cost considerations are important in safety management, they must never supersede regulatory requirements designed to protect public health. This approach represents a significant ethical failure and a direct violation of the CSB's professional responsibility to safeguard well-being. It also risks substantial legal penalties and reputational damage for the organization. The professional decision-making process for similar situations should involve a systematic review of all applicable regulations, federal, state, and local, a thorough hazard identification and risk assessment of the water source and treatment processes, consultation with relevant regulatory agencies, and the development of a monitoring and compliance plan that addresses all identified risks and regulatory requirements. The CSB must act as an advocate for public health and safety, ensuring that all decisions are grounded in regulatory compliance and ethical principles.